Okay, so I'm back with Unit 2 video lesson number 9. And we talked before that with every discovery, with every new model of the atom, there were limitations or more questions that came about. And so the limitations to Bohr's model, we see that there are 3 of them. The first one was that it only explained the bright line spectrum of a hydrogen atom and no other element. It was only good for that one atom with one electron. The second is that we still didn't have an explanation for the chemical behavior of atoms. And lastly, through experimentation, physicists determined that electrons cannot move or exist in circular paths. If they did, eventually they would lose speed and fall into the nucleus of the atom, and that doesn't happen. So they just can't exist in those circular paths like Bohr had determined or suggested. So in 1924, Louis de Broglie proposed that Bohr's quantized electron orbits had characteristics similar to waves. Now keep in mind that everything that I am talking about here was backed up with experimentation, but we're just not going through the actual experiments that led to all of these different thoughts. He also said that only odd number of wavelengths can exist in an orbit. So we questioned, if waves can have particle-like behavior, then can particles of matter, the electrons, have wave-like behavior? So that was the big question. And what he came up with is called de Broglie's dual wave particle nature of light, which says that moving particles, like electrons, have both particle-like and wave-like behavior. And this is the connection that we make to the dual nature of light, where photons have both particle-like and wave-like behavior. If electrons have wave characteristics and restricted to orbits, then electrons will have certain wavelength, frequency, and energy. So if they're in those quantized orbits and they have energy, then they'll possess the frequency that's associated with the energy, and then the indirect relationship with the wavelength. Now Heisenberg, he came along, Werner Heisenberg, and through many experiments reached a very profound conclusion, and stated that because electrons are in constant motion, it is impossible to know exactly both the velocity and the position of an electron at any one time. And so that put into question those orbits in Bohr's model of the atom, because Bohr suggested that electrons' location can be pinpointed in those electron orbits, in those circular orbit paths that are around the nucleus. And so Heisenberg is saying, no, we can't pinpoint the location of the electron because they're moving in that constant motion with a wave-like pattern. This means that you cannot assign fixed paths to the electron, or you can only predict the probability of an electron to occupy a certain region around the nucleus. And that, my friends, is the end of video lesson number 9. So it was very short and very sweet. Until next time, Mrs. Wheatley, so long for now.